So this is actually today class. So today class is Unit 5, Block 1, HCT-102. So Unit 5 intermediate. Title of the unit is intermediate. So intermediate. So you know that the covalent bond between carbon-carbon or carbon and other atoms is broken in two ways. It is broken in two ways. The carbon-carbon bond or carbon other bond. So this is also carbon hydrogen. This is carbon hydrogen bond and this is carbon-carbon bond. Carbon hydrogen bond and this is carbon-carbon bond. These two are carbon-carbon bond. So this is carbon-carbon bond. So here, if you take this one carbon as A and this one carbon B, AB, there are two types of cleavages are there. So one type homolytic cleavage, covalent bond can be cleaved into two types. One is covalent, another one heterolytic cleavage. One is covalent cleavage, another one heterolytic cleavage. What is homolytic cleavage? It is the bond is A and B. Bond is A and B. So it means same electronegativity. So if it is the same electronegativity, the same pair of electrons carries each equally. Each element carries equal electron. See, homolytic cleavage means like this. One electron on A side, another electron B side. The two electrons in a covalent bond. So it is homolytic cleavage. Is homolytic cleavage. Correct. So one electron A, another B. Equal. Homo means equal. So it carries and the same pair of bond pair electrons goes with 1 each. 1 each. Such type of bond is called homolytic. This type of cleavage is called homolytic. What is heterolytic? What is heterolytic cleavage means? This is same electronegativity difference. Same electronegativity difference. In case of homolytic. So in this electronegativity difference is more. Electronegativity is more. The bonding pair electrons goes with the ends of, so goes with more electronegative atom. Left is positive. So here same set of electrons is completely goes with ideally electronegative atom. So example for this, chlorine. This chlorine is highly electronegative. That's why same pair of electrons shift towards chlorine. It carries positive charge carbon and this carries negative charge. So it is heterolytic. So for if you want a homolytic example, carbon-carbon means carbon, one carbon is carbon plus carbon. So equal sharing here is homolytic equal sharing radical carbon. Here the due to difference in electronegativity. So breaking, so homolytic breaking. Next, due to difference in heterolytic, due to difference in high electron. So due to difference in electronegativity of chlorine is more. That's why it takes shared pair of electron towards itself and becomes negative, this plus. This type of cleavage is called heterolytic cleavage. This type of reaction is called heterolytic cleavage. So this is homolytic and heterolytic cleavage. In the organic reaction, so chemical reagent. What is chemical reaction? Chemical reagents and acid. Acid is in its substance to donate proton or accept electron. So bases, acid, bases, oxidation, is removal of electron or addition. Oxygen is called oxidation. Reduction, addition of hydrogen or removal of oxygen is called reduction. Redox means both oxidation and reduction takes simultaneously. Redox are described in terms of species. Which are which is responsible. So, in terms of which are responsible for carrying out a reaction. So that species that's carrying out the reaction. These species are generally called reagents. So these acid-base oxidation, reduction, redox are described in terms of species which are responsible for carrying out the reaction. This species is called chemical reagent. The one is responsible to carry reaction. It's called chemical reagent. See, this is actually okay. So there are two types of reagents. So this is very basic and very important for understanding organic chemistry. Organic chemistry. So what is two types? One is type 2. Two types reagents. One is electrophilic reagent. Another one nucleophilic. Another one nucleophilic reagent. I'll take first one. What is electrophilic reagent? The symbol is E plus. The symbol is any substance which is deficient. Any substance which is deficient in electron are called electrophile. Electrophilic reagent or electrophile. Electrophilic reagent. The symbol is E plus. So electrophiles are two types. One is two types. Electrophiles two types. Electrophilic reagent two types. One is neutral. Neutral electrophile and neutral electrophile anta one type irutte, innondu positive electrophile. Species do not carry positive charge. Do not carry positive charge. Do not carry positive charge. Are called what? Called neutral species. Neutral species. So here the positive charge, but so neutral charge. Idral ಏನಿರುತ್ತೆ? So empty p ಇರುತ್ತೆ. So they have empty valence orbitals. For example, the Lewis acid and aluminum chloride, so bromine, iodide. So it has, if you write this one aluminum, so aluminum trichloride has one empty p orbital. This is difficult. That's why it accepts electron from Lewis base. Is electron deficient due to empty p orbital. Accept electron. That's why it is act as electrophile. So it's easily accept electron from Lewis base. So there is empty p orbital. So it acts as deficient in electron. So it can accept electron means it wants what? Electron. So it wants electron is deficient. Aluminum trichloride is deficient in electron, but here no positive charge is simply you can write aluminum trichloride. There is no positive or negative charge, but positive charge, there is no positive charge. That's why it is neutral electrophile. Accept electron not deficient ಇದೆ. P orbital empty ಇದೆ. ಇದರಲ್ಲಿ ಸೇಮ್ ಅಷ್ಟೇ. boron empty p orbital. It easily accepts electron from Lewis base. So empty means it requires electrophile means it requires electron. So you will be empty. This requires electron. That's why it is electrophilic reagent, but neutral. But it is neutral. So this is neutral. So in the second type, positive. The second type positive electrophile. So positive electrophile. Next, the positive electrophile. So it carries electrophile, carry positive charge. It's called positive electrophile. So maybe carbocation. So carbocation. So many H3O plus, hydronium ion, chloride ion, bromide ion, iodide ion. So it accepts so nitronium ion, nitrosonium ion, this nitronium ion, the nitronium ion. Which these all groups are accept electron. So it requires electron. That's why it is, but it is carries positive charge. That's why it is positive electrophile. So if you add any nucleophile, Cl minus, nucleophile, accept what? One more Cl minus. This accept electron, but carries positive charge. That's why it is positive electrophile. These are two types of electrophiles. Next, what is nucleophile? Second type. Any substance which is rich in electron is called nucleophile. Nucleophilic reagent. Any substance which is rich in electron is called nucleophilic reagent. Illustrate two types here. Neutral is one neutral nucleophile, and write like this: neutral nucleophile. So lone pair iruttಕ್ಕಂತ. For example, amine, NH2, alcohol, ether. So ether, these are all as lone pair. Lone pair. It easily donate electron. It easily donate electron. So these are all neutral nucleophile because here no charge, but due to lone pair in nitrogen, oxygen, and here nitrogen in sulfur, it easily donates this lone pair to electrophile. Donate means rich in electron. Already rich in electron, donate whatever. That's what is nucleophile. Neutral, no charge. That's a neutral nucleophile. Next one, second type in the nucleophile, it is negative. Negative nucleophile. Negative nucleophile. So chlorinium ion, bromonium ion, radonium ion. So OH minus, carbonium ion. These are all what? Rich in electron. What? Rich in electron. But what? But rich in electron, but carries negative charge. It easily donates electron to electrophile. It can donate electrophile. This minus charge carries, so donate electron. This also donate electron. So that's what is negative nucleophile. Now rich in electron. Any substance rich in electron is called nucleophile. So that's what is negative nucleophiles. Next, amphibians. And the next one, next one is amphiphilic reagent. Amphiphilic reagent. So amphiphilic reagent again, it acts as both electrophile and nucleophile. So for example, water. Hydrogen kodutte. So daily it donates pair of electrons and also hydrogen split again agirutte. OH minus irutte water le. So it accepts electron from nucleophile and it can donate electron to electrophile. Nucleophile inda H ತಗೊಳ್ಳೋದು electrophile ಇಂದ OH electrophile ತಗೊಳ್ಳೋದು. That's what is amphiphilic. ಅದೇ ರೀತಿ cyanide. R C double bond in. It accepts electron from here, nucleophile. Don't get rid of it, donate electrons to electrophile. So both. So cyanide, even aldehyde, it accepts the electron from nucleophile, and it can also donate electron to electrophile due to oxygen lone pair. That's why it's amphiphilic reagent. It attaches both electrophile and nucleophile. So if it is in the organic reaction, to consider an organic reaction of the type, if A plus B gives C plus D, the product, any reaction, two reagents, A and B reacts to give C and D. Here, it follows if A, B reacts to give intermediate X star, and this after transition state, it gives C and D. So, in this chapter, in the organic, we have to study these intermediates. What are intermediates? This intermediate may be the carbocation, carbanion, nitrene, or carbon radical, carbon radical, any. These are the intermediates. But in this class, we are going to study is carbocation intermediate. Carbocation intermediate. Carbocation intermediate. The first intermediate, carbo. So carbon bearing a positive charge. Carbon bearing a positive charge are called carbo charge are called carbocation. The carbon bearing positive charge. This carbon bears positive charge is called carbocation. This carbocation. So how to generate this carbocation? There are many methods are there for generation. Methods for formation. Methods for formation. Methods for formation. Methods for formation. From one method A, dissociation of alkyl halide. Alkyl halide. The simple reaction today CS3 ಇರುತ್ತೆ ಇದನ್ನ ವಾಟರ್ ಹಾಕಿದ್ರೆ ಟರ್ಷರಿ ಬ್ಯೂಟೈಲ್ ಕ್ಲೋರೈಡ್ ನ ಸ್ಪ್ಲಿಟ್ ಇರುತ್ತೆ ಏನಾಗುತ್ತೆ ಡಿಸೋಸಿಯೇಟ್ ಆಗುತ್ತೆ ಡಿಸೋಸಿಯೇಟ್ ಟು ಗಿವ್ carbocation. This is the one best method for generation of a generation method of formation for carbocation. See, so tertiary butyl chloride, using tertiary butyl chloride, it dissociates to give one Cl minus and next one carbocation. This is the one method. The second method, amine from this B. The primary amine, treat this hydro HNO2 and HCl. It gives azide. By heat this, you get R is plus. Here R may be alkyl. This R is alkyl. Alkyl means maybe CS3, it may be CS2, CS3 methyl alkyl. R is maybe CS3 plus CS2 plus CS3. The second method from what? Amine. From amine. First method from alkyl halide. The second method means C from aromatic compound. For aromatic compound, just add electrophile. The presence of base such as Lewis. In presence of Lewis acid. Attach this and generate this carbocation. Electron can accept the attack. So this is acid, Lewis acid. So this is the generation of from aromatic compound in the generated one. So many methods are there. From alcohol in the digit ಮಾಡಬಹುದು. Take from alcohol, fourth. Alcohol, presence of vegetables, E. That is positive charge. Elimination of one. From alcohol. Methods of formation. This alcohol and what X the one eliminator. This generates carbocation. Carbocation. The next is very important. Structure. So carbocation structure. Structure. So we know that the hybridization of CS4 is sp3. It draw this one electronic configuration is like this. Carbon. C6. This first one is diagram. This 2s, 2px, y, and z. The remaining 1, 2, 3. So these 2 remaining 2. So 1 then empty carbon. After hybridization with 4 hydrogen, it bonded with 4 hydrogen. So this is only carbon. After bond after write this after bonding. Hybridize form. CH4. This one is excited state. sp3, 1s and remaining 3p. Okay, then sp3. Hybridize so hybridize next step one electron use each one electron into H, and this is H. This shift time. Shift so you can write like this. Excitation. This one electron shift here, form this one. 4. This 4 one electron, 4 electron. One on the hydrogen. One or two electron from hydrogen. So this is called sp3 hydride and CF. If carbocation one of the hydride is shifted, generate this is means 1H minus N. And the sealed pair of electrons will complete again empty hydride reaction in the next year 1, 2, 3. Next 1, 2, 3. This one higher step. Here step na hybridize plus ಇದು ಹೋದ್ಮೇಲೆ after this ಅದು ಕಂಪ್ಲೀಟ್ ಎಂಟಿ ಆದ್ಮೇಲೆ ಒಂದು ಎಂಟಿ ಪಿ ಆರ್ ಇದೆ. ದಿಸ್ ಎಂಟಿ ಪಿ ಆರ್. ಈ ಎಂಟಿ ಪಿ ಆರ್ ಗಳನ್ನ ಈ ತರ ಬರ್ಕೊಳ್ತಾರೆ. This is empty p orbital, and this one first hydrogen, and next this one another hydrogen here, next hydrogen, this one, and this is and this is for empty p orbital. This empty p orbital. Empty p orbital. So this is actually this one. This is the structure of what? Carbocation. Yes, plus. This plus is empty p orbital. Empty. And this is hydrogen. This is CS3, and this is CS. So here, the first point, carbocation or sp2. Sorry, is one is another sp2 hydrogens. Carbocation is R sp2 hydrogen. Second point, one empty p orbital, empty p orbital is perpendicular to the plane of carbocation. ಈಗ trigonal ಅಂದ್ರೆ ಇದು. This is trigonal. What is the bond angle here? Bond angle the bond angle is 120 degree. So bond angle 120 degree. See, this is CS3 plus charge plus empty p orbital, remaining 3. What's the hybridization? One complete hydrogen. Hydrogen H minus complete remove empty orbital. This is the structure of bond. Structure of what? Carbocation. How many sigma bonds? 1, 2, 3. Fourth point. Bond angle 3 sigma. So this is about structure of carbocation. This is the structure of carbocation. Next, stability of carbocation. So stability of carbocation is tertiary carbocation, and next this is secondary carbocation, and next is tertiary, secondary, and this one primary, and this methyl carbocation. Primary. So here and then, so you know that CS3, any alkyl or any substituent to carbocation. So any substituent, electron donate towards charge, positive charge electron push substituent. Carbocation substituent, carbon positive charge substituent bonded electron push is already deficient. It needs electron. Push it stabilizes the carbocation. Only 3 atoms. So alkyl is electron donating group. Electron donating groups. Here 3 donating groups is there. That's why it is more stable. Here only 2. That's why it is compared to this next. Here only 1 carbon. CS3 is pushing toward this carbon. So here so this is called inductive effect. It only acts in sigma bond, inductive effect. Partial. So it push CS3, partial acquires positive charge, partial acquires negative. electron ikkada push agadrinda partially plus negative, partially positive. That's what is plus I effect. Plus I inductive effect. Substitute in plus ತಗೊಂಡ್ರೆ partial charge ತಗೊಂಡ್ರೆ plus I effect ಅಂತ ಕರಿತೀವಿ. Same, it operating only in the sigma bond. So due to partial displacement of shared pair of electron in a bond towards positive charge, stabilizes the carbocation. So that's it. This type of shifting of electrons towards the carbon is called plus inductive effect. Due to inductive effect, this tertiary is more stable than secondary due to inductive effect, and then primary. So carbocation is built. Next inductive effect are resonance effect. Second one, resonance. Okay, benzyl carbocation. So due to double bonds, the alternate to carbocation is shift here. See, this form positive charge here after reducing this electron towards this. So this carbocation again is stabilized by this adjacent double bond. So this carbocation again is stabilized by next structure. After shifting here, this generates here positive charge. Again, this stabilized by this. Yes, see. The positive charge is total three resonating structures are stabilized by three resonating structures. That's why resonance stabilizes positive charge. Means carbocation. Resonance stabilizes. How it stabilizes? By like this. Stabilizes carbocation. Next, third one, hyperconjugation. Hyperconjugation also stabilizes. See, if this is the compound, there is a positive charge. There is positive charge. Positive charge. No bond resonance ಅಂತ ಕರಿತೀವಿ. ಇದು H ಇಲ್ಲೇ ಇರುತ್ತೆ. H plus. No bond ಕನ್ಸ್ಟ್ರಕ್ಟ್ ಆಗುತ್ತೆ. H plus ಇಲ್ಲೇ ಇರುತ್ತೆ. H ಇಲ್ಲೇ ಇರುತ್ತೆ. ಇದನ್ನ ಏನಂತ ಕರಿತೀವಿ? hyperconjugation. No bond resonance. H ಇಲ್ಲೇ ಇರುತ್ತೆ. ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಶೇರ್ ಆಗಿರುತ್ತೆ, ಬಾಂಡ್ ಆಗಿರುತ್ತೆ. ಬಾಂಡ್ ಮಾತ್ರ ಶಿಫ್ಟ್ ಆಗಿ ಕಾರ್ಬೋಕೇಟನ್ ಸ್ಟೆಬಿಲೈಸ್ ಮಾಡಿ. How many times it stabilizes? One more is there here. In the left upside and one more upside ಆಗಿರುತ್ತೆ. ಇದಿರುತ್ತಲ್ಲ lower one. This stabilizes this one. ಅದೇ ರೀತಿ if it is all three are hydrogen is hydrogen is there 3 times like this. First carbon, one serine. Next second serine, first hydrogen in for this hydrogen. First hydrogen, next hydrogen. Take this hydrogen. Plus ಆಗಿರುತ್ತೆ upside current ಆಗಿರುತ್ತೆ. ಇದು yes. This third one no bond. Here is the Second one, no one. Here, first one. This is called hyperconjugation. Hyperconjugation. Correct. This effect is called hyperconjugation. This hyperconjugation. This stabilizes the carbocation. See, one non-classical, two types of carbocation, two types of carbocation, classical, A classical, B classical. Up to a general, it is a classical. This is what we study about classical. What is non-classical? If you take this as an example, this is classical. This is classical. If it is bonds like this, tri-coordinate value ಏನಾಗಿದ್ರೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ 3 ಕಾರ್ಬನ್ 1 2 3 ಸಿ ಇಲ್ಲಿ ಈ ಬಾಂಡ್ ಗೆ ಶಿಫ್ಟ್ ಆದಾಗ ಕಾರ್ಬನ್ ಸೈಡ್ ಇದು tri-coordinated carbocation are called what? This tri-coordinated carbocation are called non-classical. This is non-classical carbocation. Tri-coordinated ಏನಂತ ಕರಿತೀವಿ? Non-classical carbocation. ಶಿಫ್ಟ್ ಆದ್ರೆ ಕಾರ್ಬೋಕೇಟೈನ್ ಆಗಿರೋದು ಪಾಸ್ ವ್ಯಾಲ್ಯೂ 3 ಕಾರ್ಬನ್ ಗೆ ಅದು ಏನಾಗುತ್ತೆ ಸೇರ್ ಆಗ್ತಾ ಇರುತ್ತೆ, ಅದನ್ನ non-classical ಅಂತ ಕರೀತೀವಿ. Next, last reactions. So very important is reactions. The reactions ಅಲ್ಲಿ ಎಲ್ಲಾ ಟೈಪ್ ಆಗುತ್ತೆ. Substitution. First I will take substitution. So already I discussed butyl, tertiary butyl chloride dissociate to give this molecule carbocation Cl minus. And next step, there is a OH minus is attached to this electrophile. This is nucleophile and form tertiary butanol. So here chloride is substituted by OH. This is called substitution via intermediate carbocation. This is the substitution reaction. One, chloride dissociate ಆದ್ಮೇಲೆ carbocation form ಆಗುತ್ತೆ, carbocation ಗೆ OH substitute ಆಗುತ್ತೆ. This is chloride substitute by OH, that's its substitution reaction. This is called SN1 reaction. SN1 reaction. So it is in the rate step, it involves only one reaction. So nucleophilic unimolecular substitution reaction. Nucleophilic unimolecular. Only one rate step. Unimolecular substitution reaction. Next. The next step, elimination. Second one. Elimination. So elimination, let's take alcohol. This gets H. Just add H2SO4. It will take proton from H, and the next step from 4H2 H. In presence of base, so it takes this proton and this eliminate this water, forms what? B. Forms what? See, elimination, if you take ethanol, this is ethanol. So H2 super protonation takes proton and forms water here. And the next step base active. Base is hydrogen and this pair of shared pair of bond shift toward this, it eliminates this water to form double bond here. So this is alkene. This alkene. Residuals for function always, so alcohol is residuals for always protonates. Proton na add ಮಾಡುತ್ತೆ. So this is elimination. So elimination it takes oxidation, sorry, addition. It is CS3 already generate ಆಗಿದ್ರೆ just add for this addition. ಏನಾಗುತ್ತೆ? CS3OH. Addition reaction. Addition reaction. This methyl carbocation. Methyl carbocation. This OH minus hydroxyl. The OH minus. This adds to this. This is addition reaction. Addition reaction. The last reaction, rearrangement. These are only 4 types are there in the organic chemistry. It's very important as for organic chemistry. We'll layer so first rearrangement discuss. If you take this in a compound, ODS, this bulky group ODS, fossil group. ಇದೇನಾಗುತ್ತೆ ಡಿಸೋಸಿಯೇಟ್ OTS ಡಿಸೋಸಿಯೇಟ್ ಆಗುತ್ತೆ. This keep OTS out CS3. So CS3 OTS. The OTS remove ಆಗ್ತಿದೆ bulkier group forms carbocation. This is CS3 and this is CS3. See, this is secondary carbocation. ಇದೇನಾದ್ರು alkyl shift ಅಂತ ಕರೀತೀವಿ. This shift here, after shifting of this one, the generated carbocation is tertiary. So this is tertiary. This is secondary. So after generate, Indian shift ಆದ್ಮೇಲೆ secondary is unstable compared to tertiary. That's why alkyl shift 1 to alkyl shift ಅಂತ ಕರೀತೀವಿ. After shifting this alkyl, it generates what? Tertiary carbocation. That's why it is stable. So CS3 ಏನಾಗುತ್ತೆ shift ಆಗುತ್ತೆ. ಇಲ್ಲೇನಾಗಿದೆ secondary carbocation ಈಗ. ಇಲ್ಲಿಂದ shift ಆದ್ಮೇಲೆ it generates tertiary carbocation. That's why it is more stable. That's why it is ಏನಂತ ಕರೀತೀವಿ. So alkyl shift ಅಂತ ಕರೀತೀವಿ. So alkyl shift. ಇಲ್ಲಿ alkyl ಇದೆ alkyl shift ಅಂತ ಕರೀತೀವಿ. In case ಅದೇ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಇದ್ರೆ 1 to hydroxyl. ನೋಡಿ ಇಲ್ಲೇನಾಗುತ್ತೆ OTS ರಿಲೀಸ್ ಆಗಿರೋದು H ಚಾರ್ಜ್ ಬರುತ್ತೆ H. It is secondary carbocation here. So it's going to one hydrate shift ಆಗುತ್ತೆ 1 to hydrate shift. 1 to hydrate shift ಆದ್ಮೇಲೆ so this one hydrate and CS3. So this forms tertiary equivalent. This hydrogen shift. ಎರಡು ಆಲ್ಕೈಲ್ ಅಂದ್ರೆ ಆಲ್ಕೈಲ್ ಶಿಫ್ಟ್ ಅಂತೀವಿ 1 to ಆಲ್ಕೈಲ್ ಶಿಫ್ಟ್ ಅಂತೀವಿ. 1 ಆಲ್ಕೈಲ್ ಅನ್ನೋದಕ್ಕೆ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ ಔಟ್ ಆಗುತ್ತೆ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ ಇಲ್ಲಿ ಬರುತ್ತೆ ಕಾರ್ಬೋಕೇಟನ್ ಇಲ್ಲಿ ಬರುತ್ತೆ. So that is shift. This is next step ಅಲ್ಲಿ any nucleophile attaches carbon and forms the silent product. This one is the product answer. After carbocation, tertiary carbocation. Any nucleophile you have, it forms product. So this is rearrangement. This is rearrangement. See, you organic chemistry of kalibeku andre, these things are very important. So what I discussed here today are very important. Very important. So what is cumulative cleavage? Summary level adre, these are very important. Cumulative, and then intermediate cleavage. Intermediate. After that, then generate aito. Intermediate to carbocation, carbonyl. Intermediate, so it's got intermediate. So information to intermediate. How to generation. So it's really so formation of stability, reactions. ಇದೆಲ್ಲ ನೋಡಿದ್ರೆ ಅದಾದ್ಮೇಲೆ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್, ವಾಟ್ ಇಸ್ ಎಲೆಕ್ಟ್ರೋಫೈಲ್? ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಎಲೆಕ್ಟ್ರೋಫೈಲ್ ಇದೇನೋ. ನೆಕ್ಸ್ಟ್ ವೆರಿ 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 ಇಂಪಾರ್ಟೆಂಟ್, ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಅಂದ್ರೆ ಏನು? ವೈ ಇಟ್ ಈಸ್ ಕಾಲ್ಡ್ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್? And examples already I discussed examples also. Nucleophile. And very important, I will discuss what is a substitution reaction. Substitution reaction. What is next? Addition reaction. Add or addition reaction anta karitive. Next, third one, elimination reaction. Elimination reaction. Eliminate adre molecularly any element around group, that is called elimination. Addition adre molecularly addition. Substitute adre bere adre chloride to OH substitution. The fourth one, rearrangement. So why they rearrange this? We saw in the last example. These are the summary of the unit. So you should, if you at least practice madare, you'll get complete idea of organic chemistry. Okay. So I will thank you anyway. I will stop this class today here. So you can any doubt?